Hello everyone, welcome back to RKodeAcademy. Have you ever wondered why Java is called as an object-oriented programming language? The answer is very simple. Java helps us to build a large scalable application by following object-oriented programming concepts and principles. These are the concepts. Those concepts are followed while you are implementing the code or instructions over there in the language Java. That's the reason it is called as object-oriented programming language. But instead learning theory, let's explore it in our code's way. Let's imagine you are joining us in software company today as a software developer. Assume on your first day your manager says, we have a new project, build a food delivery application like Swiggy or Zomato, right? Now, let me know, will you immediately start writing Java code for that application? Of course not. A good developer first understands the business, yet you start identifying the things involved in the application. Assume that your application is become a food delivery application like Swiggy or Zomato. So the real world entities are involved in that applications are the restaurants, customers, orders, delivery partners, payments, etc. These are all the real world entities. We have to consider these things in order to develop that application. So all these real world entities collectively called as objects in Java programming language, right? Everything else in Java revolves around object. Okay. For clear understanding, let's take one object. So as I said, there are two primary entities. One is object. So everything that you are going to follow will be there in the fashion an object. The second one is called class. The rest of the principles are just follow these two things. Okay. So coming to the point, let's take one single object as restaurant. Assume this is a single object. What are all the things has to be considered with the restaurant? If your application needs to store a restaurant, what information should I have? The restaurant should have the restaurant name, location, menus available, the rating, and time of open. These are the characteristics of the restaurant, right? In Java, these are all called as member variables, or we can call in technical state of that particular object. Okay, so these are the things which is used to store the information related to that particular object. Hope it is clear. All these are member variables. These member variables are used to store the relative information about that particular restaurant. So it can be called as member variable, or in a technical term we can call it as a state of the object. But a restaurant doesn't just store the information, it also perform actions, right? So actually it is accepting the order. Based on the acceptance, it will prepare the food. After preparation of the food, it will create the bill or calculate the bill. So once the bill is generated, will generate the invoice, and the menu updations will be there, like many more functions also there. These functions, what are all the task has been done through this particular restaurant, are called as member functions or method we can call. Okay, so here we can conclude that every object have two things. Here there is an object, right? Every object has two things. One is members, the another one is called methods. Okay, so here the members are used to represent the state of the object, to store the information about the object, whereas the methods will provide you an ability to perform the functionality related to that object, right? Assume we are able to have members and methods for a particular object, but here the problem is it does not alone a single restaurant. That particular restaurant have 5,000 branches. Should we need to write the same variables and methods 5,000 times? Is it so? So assume that restaurant have 5,000 branches. So or we need to declare the variable like restaurant name, location, menus, and all those things for individual 5,000 restaurants. If so, so assume there is 5 variable for one single restaurant. For 5,000, 25,000. Okay, 25,000 variables we need to declare, right? That is not in the case. Here, in order to avoid that, the Java gives us a special provision that is called as class. Okay, we define all common variables methods only once inside the class. Okay, even there is 5,000 restaurant, for all the restaurant, name of the restaurant is common, the location parameter is common, and the menus may be common, menu items may be common. So they can able to store different items, and to store all the menu items, the variable is common, menu is common, right? So billing and everything is common, most of the things are common. All these common terms are binded together inside the concept which is called classes. Then we can create as many objects to show the difference in the object state. Okay, for example, name of the restaurant in one location is X, the name of the restaurant in the another location may be XX. Okay, name of the another restaurant may be Y. Okay, the name can be changed based on the object, not by the class member variables. Hope it is clear. Okay, now so everything put inside the class, as I said, you just can able to look at it now. So this is the binding. Inside that, restaurant name can be there, restaurant location can be there, menu items can be there, everything can be created inside this class. Okay, assume there is a class, the class contain all the necessary information about that object, state of the object. Now this particular object can hold all the things, but it is not easily accessible. Okay, this concept is called as encapsulation. We are placing everything over there in the class, but at the same time we can see here we locked it. Without the permission of the particular owner, this data cannot be acceptable. Okay, clear? Now imagine anyone in the restaurant can directly change the prices, bills, or menu items. It would create complete confusions in the restaurant, right? Instead of that, the restaurant allow only the authorized staff to make the changes. That authorized staff is protect that particular informations, right? So that is called the encapsulation. Let's explore all these things are in the concepts later. As I already told you, these are the things are called concepts. These will be implemented by the programming instruction the later stages. Hope it is clear. The next one is called as an abstraction. Okay, what do you mean by abstraction is assume that you are having a fan in your home, right? So the fan may have a remote to operate it. Okay, so you are hit the power button once the fan is getting switched on, but you don't know once the clicking of the power button how the fan is getting on. There is some kind of operations happen, right? You doesn't know what is that operation it. When you hit the button, the fan is getting on. That's the thing that you explicitly known. This process is called abstraction. For some event there should be an action, but you doesn't even know what is the triggered operation happened in between or in the behind to perform that particular action. You doesn't know. Those information is hidden, which is called as an abstraction. In Java also you are going to you are going to implement the abstraction, so essential things may be hidden in order to achieve some higher securities. Okay, and the next one is called as inheritance. Now assume that particular company launches a cloud kitchen. Okay, the cloud kitchen also needs menu, order, customers, and billing. Instead of creating everything from the scratch, it directly uses some essential features from the existing restaurant class. Okay, you can see this example, right? You can see this example here. Okay, I will show you. You can see this example here. There is a power socket. The power socket are capable of connecting a 2-pin connector or 3-pin connector or USB connector or different form of connectors. The mean is there is only one parent class which have the common information. That common information can be shareable to the children's, that is called inheritance, right? The next one is called polymorphism. Okay, so assume there is three electrical devices, right? There are three electrical devices. All these devices are having the power button, correct? So each power button are, the power button is a common term, but each power button is taking the responsibility to on the corresponding electrical device, right? So the same button, but it is acting as different functionalities in the different machines. Wherever there are different machines, in that particular different machine it acts as a different functionalities. Okay, these are the four major functionalities. Along with the members and objects, we have covered some 6 important concepts. Apart from that, there are two things. One is dynamic binding. So during the execution time you can bind the function calls, that is called dynamic binding. And one more, those are the for foundational programming concept. During the program implementation we can learn those things, and then message passing, we can share the information between the objects, which is called message passing. These two are the additional two functionalities about that particular OOPS principle. There are 7 principles. Apart from that, 3 more things that we have to concentrate. One is called modularity. Okay, when you are designing an application, but that particular application is grows enormously, the application sizes grows in linear way, so that application can be divided into the module. For example, assume that Swiggy application, right? For Swiggy application, the user have to be login. The login process are controlled in terms of login module. And there is a restaurant to accept the order. There is a module which is called restaurant module. To process the payment between the customer and the restaurant, there should be a payment module. Okay, and delivery operations, once the order is success and the payment is done, they have to be delivered. There should be a taken care of concept which is called delivery model. And once the delivery is initiated, it has to be notified to the user, right? There is a notification module. Like, from the entire operation of that Swiggy delivery application has divided into different small application. Those applications are called as modules, and the small part of the code which can be executed independently. These are called as module, right? So a larger application can be divided into the small section which is called module. Okay, and the coupling. The coupling is, we know the modules, right? The login module. The login module can be executed independently. It should not depend to some other module, or the dependency should be very minimum in the case. For example, restaurant module. The restaurant module, what are the things it can be do? It can receive the order. After receiving the order, they will prepare the food. After preparing the food, they will create the bill. Once the bill is getting created, they will generate the invoice. That invoice will be shared to the payment module. Alright, so only one functionality is dependent to the next module. Rest of the things can be executed independently. Between two different models, the connectivity should be minimum so that the application can be able to execute very well. This process is called as coupling, that is minimizing the dependency between the modules. Hope it is clear. And final one is cohesion. So assume there is an what we can say, there is a modules, different modules are there. Let us assume there is a restaurant module. The restaurant module, some of the things has to be binded together. For example, the order is received. Once the order is ready, then the preparation should be start. Immediately the preparation should be start. Once the preparation is getting completed, they have to be notified the customer the preparation is ready, your order will be dispatched soon. Okay, these are the things are connected with each other inside the same module. Inside the same module, when there is more number of functionalities are connected together or binded together closely, then this is called cohesion. Okay, so this is just like you can see this when you are having a toolbox, all the related tools will be there, because based on the task you can access the tools as fast as possible. This process is called as cohesion. Okay, so according to the application, the coupling should be minimum. At the same time, the cohesion should be high. Okay, now you know why the Java is called as object-oriented programming language, right? Professional Java developer don't start by writing just code. They first identify the object. After identifying the object, they have to bind everything inside the class. After that, they can apply the concept called encapsulations, abstraction, inheritance, polymorphisms, modularity, coupling, cohesion, and all these are help you to build a software that's secure, reusable, scalable, and to maintain easily. Okay, that's exactly why Java powers the lot of applications, okay, in different domains. The next video we will dive deep into the concept called what is actually the object is. Until then, keep learning, keep coding, and keep growing with our Code Academy. Thank you.